Okay, ladies, so this is section 2.4, which you should have the packet for. If you don't have the packet, I left extra, so if you were not in class or you didn't receive a packet, I left one outside of my office for you all to receive one. Remember that we will not have class this Friday, so let's get started. And this is for my fall 2018 semester students. Okay. In this section, you have the objective. So we're going to use the imaginary unit I to write complex numbers, add, subtract, and multiply. And I'll let you read the other two. I want to get into it because I try not to let the videos be over 15 minutes. I might have to break this up into 2 videos. It just depends on how fast I go. So I need to stop talking now and get started. All right. Well, I is equal to the square root of negative 1. And this is called the imaginary unit I. And I squared, well, if I is negative 1, then if you square that, I squared equals negative 1. Okay. And so a complex number, the definition for a complex number is a number in the form a plus bi, where both a and b are real numbers. Okay. And each complex number can be written in the standard form a plus bi, right? Well, if you think about this, then if b is equal to 0, right? So if b is equal to 0, then a plus bi will just equal what? Very good, a, right? And if b does not equal 0, the number a, and so that means this is a real number, right? So a, which is just going to be a real number. And so if b does not equal 0, the number a plus bi is called imaginary number. And a number of the form bi, so that's where a is equal to 0, where b does not equal 0, it's called a pure imaginary number. Okay. And let me just say here that if you think about it, since when b is 0, a plus bi equals a, and that's just going to be a real number, then the complex numbers are a larger set than the real number, right? So if you think about the number system being nested in each other, the complex are overarching, then comes the real numbers, and then the reals can break up into the rational, irrationals, and then within your irrational numbers, you have your integers, your whole numbers, and things of that nature. Okay? All right. So let's write this in standard form. Before we do that, let's recall, I want to just bring back to your memory the fact that if we have the square root of a times b, not a plus b or a minus b, but a times b, then that's going to equal the square root of a times the square root of b, right? We can separate that. And this is also true if we have the quotient. So the square root of a over the square root of b is the square root of a divided by the square root of b, right? Let me put this in red. Warning. Why did I say it like a police siren? Okay. Warning. The square root of a plus b does not equal the square root of a plus the square root of b. So be very careful. Also, the square root of a minus b does not equal the square root of a minus the square root of b, right? Those are not true statements. And when you're in doubt, just plug in a number to see if it would make sense or not. Okay, so keeping that in mind and knowing that our standard form is a plus bi, let's write negative 3 plus the square root of negative 4 in standard form. So, well, negative 3 is sort of representing this a term here, right? And so now we need to rewrite, we can rewrite 4 as 4 times negative 1. And now we know that we can break this up into the square root of 4 times the square root of negative 1. And that tells us then square root of 4 is just 2, right? And square root of negative 1 from the first page is now I. We know that to be I. So now we have placed this in standard form. Okay. Right. Let's move on. Equality of complex numbers. All right. Well, given a plus bi is equal to 13 plus 4i, find real numbers a and b such that this equation is true. Well, I know you're looking like it just seems straightforward. It really is, right? You line up the terms. So A then will be what? 13 and B will be 4. Okay. Hopefully that made sense. And let's look at example 3. So 7, so write in standard form. Okay, so simplify, write in standard form. Well, let's put the pieces together. The addition is commutative, and so we can write this as 7 minus 5, right? And then plus I plus 6I. And so that's going to be 2 plus 7I, and that's our standard form. Let's look at B. B is, first, since this negative sign is there, okay, since that negative sign is there, be very careful because that needs to be distributed, right? That negative to each term. So let's distribute that to each term first. And so before we start our work, that'll be negative 4 minus 3 root 2I, okay? Now let's put things together. Well, we can put the real terms together. A minus 4. Well, sort of negative. No, okay. And then we can look at 18 as what? 18 times negative 1. And then minus 3 square root of 2I. And so that's going to become 4 plus the square root of 18 times I minus 3 square root of 2I. Now, in fact, you should recall from algebra, maybe back in the day, but you should recall that 18, you can break that up. So let's make this sort of a side note. Okay, and this is for the square root of 18. Now, this isn't a perfect square, meaning it's not like square root of 4 is 2, square root of 3. And again, so square root of 4 is 2 since 2 times 2 equals 4, right? So in terms of 18, can we think of perfect square in it? Well, we can factor this into 9 times 2, and then this will be 3 root 2, right? So square root of 18 is 3 root 2. So now we have, go back now to this is going to equal 4 plus 3 square root of 2I minus 3 square root of 2I. And what if you know that cancels off? So this equals 4. But whenever they ask you to write it in standard form, you just put, and if the B term doesn't exist or it equals 0, just write it as that. Because that's representing standard form. Okay. So hopefully this section should be really straightforward once you understand that sort of the square roots. That might be the only thing if you haven't seen this in a while, but it really should be pretty straightforward. Okay, let's move on. You guys are doing good. Yeah, it's just like we're in class. All right, so now let's multiply complex numbers. It's just like multiplication, and you just have to remember. So let's just put aside here that I squared is negative 1 and I is square root of negative 1. Yes. Okay. Sorry, all right, I'm not feeling too well right now, but I'm going to push through this video. All right, so 4 times the quantity negative 3 plus 5I. If we distribute that to both terms, it'll be negative 12 plus 20I. Okay, so that's our final answer there. B takes, I want you to pause the video and see if you can try B on your own to get your final answer and write it in standard form. Okay, welcome back. And your final answer should be 24 plus 0I. Now, I will say this. If you did not get that answer and you don't understand how I received that answer, then in class on Monday, make sure you ask me to go over this. All right, but I do plan on having a review, but ask me about this question if you didn't get it. Or you can send me a message in group me if you didn't get it over the weekend if you have a question. All right, let's look at C. So C, we take each term. I know some of you like to call it FOIL. I don't like that word because it only works for certain problems. And when I teach you things, I want to teach you things that work no matter what. So all you need to do is remember to multiply each term in the first by each term in the second. So then 7 will be multiplied by each term in the first. And then this negative 2i will be multiplied by each term. 7 will be multiplied by each term in the second, and negative 2i will be multiplied by each term in the second. So let's see. So that's going to be 21 minus 35i, right? And then minus 6i plus 10i squared. Well, this will be 21 minus, so 35 minus 6, I believe, is a negative 41i plus 10i. Well, I squared, we can rewrite that as what? Negative 1. Very good. And so we get 21 minus 41i minus 10. So the final answer is 11 minus 41i. All right, moving right along, ladies. And so two numbers of the form a plus bi and a minus bi are called complex conjugates. Okay. All right, and so let's see. Okay, so state the complex conjugate, of 9 plus 2i, and then multiply by its complex conjugate. I don't know what's going on. I said, okay. Let's keep it moving, ladies. So the conjugate of 9 plus 2i is what? Good. 9 minus 2i, right? And so we're saying let's take these two terms and multiply them together, and then do what we did in last, and let's see what happens. Okay, so the power of technology is that I can pause and finish the problem, which I did. Yay. So the final answer is 81. And so all I did was take each term of the first and multiply by each term in the second. So that gave me 81 minus 18i plus 18i minus 4i squared. I squared is negative 1. So that's 81 minus 4 times negative 1. And so that gives us 85. Now let's look at this, write a complex quotient in standard form. And the way you do that, so the setup for this, and this is, I put 1i, but I really could have just wrote I. So 6 minus 1i is just 6 minus I, and then 1 minus 2i, right? Now the way that you, so write this in standard form, because right now it's not in standard form. Remember, it needs to be in the form a plus bi, and now it's not. But so the rule or the strategy to do this is to multiply by the complex conjugate of the denominator in the top and the bottom. So that will give us 1 plus 2i divided by 1 plus 2i. So we did not change. So let me emphasize, we did not change the problem, right? Because all we did was multiply by a form of 1, and any number multiplied by 1 will just give you that number. And so we're going to, should know how to multiply. Just multiply straight across. And so let me put it on one line first. So that'll be 6 minus I, and it's 1 plus 2i, right? Divided by 1 minus 2i times 1 plus 2i. Go ahead and pause the video and see if you can multiply the top and multiply the bottom through. All right, we're back. And so hopefully once you multiply the numerator, you end up with 8 plus 11i, and the denominator equals 5. So what that tells us, in standard form, we can write this as 8/5, which is our a part, plus 11/5 times I. So hence a plus bi form. Okay, so I think I'm going to stop this video here and then start the next video. We only have a little more to go, so the next video shouldn't be too long. All right.